Oh, well.
Good to go.
I guess this isn't a problem. If I'm going to be projecting to the back of the room, probably about as loud as I need to get. So let me know. Yeah.
Try it again.
Okay, so we have the Pandas. It's been updated in the past couple of years. Holy moly, it's gotten amazing results.
You're doing okay. Should we set up the laptop? Only person doing it today, so I need to... Well, the other presenter.
Yes. I'll see.
You want to at least get the ready?
Okay.
The he has the link. Yes. You want to pull it up because we're using. Okay. I could see your video on the screen
now.
Thank you. Whoa. Then I've seen you in like 5 years. Yeah, I know. Make sure the TV's plugged in. Good thing to check.
Oh.
Oh, you're supposed to. So it's not plugged. Okay. Like that.
Whoa.
Okay. Swap you in.
Signed in. To let that in.
Oh, enjoy.
All right. I'm asking to be let in. No, me. Oh, sorry.
Oh, you're not the me. How's it going? Oh, well. What you?
I didn't. I know the leader of this San Diego PHP group. He lives across the street from me. Huh? Yeah, John.
Does he still use
Let's see. He uses PHP for his business. Linux telephony.
I see the irony.
Wow. That's a lot of work.
I don't know if this is so useful, but I mean,
Not anymore.
Python is the slowest language.
It's
It's
the
easiest
easiest
for
for
scripting. I love it. When it comes to energy.
Yeah.
But I love Python.
It depends on. With that.
So, well, so yeah, we get started in like 5 minutes. Right now we're in awkward go on the live stream. I feel like that's been my goal for like exactly 7.
I see it.
Alright, I'll close everything up. Hello. I only wrote down 5.
Are you doing names?
All the names at like 5 p.m.
I don't even know what it is. I'm just being silly.
There were 21 people signed up on I think. But nobody gets
And then it's free for all.
yeah.
JFrog's like,
Oh. At least I don't think so.
what is
The Pi portal. Let's see. Hopefully nobody but Qualcomm. You know, that would be fortunate for them.
Did we have a notification?
It's been a little weird. I got 2 meetups for today. Gordon, is it Gordon? Gordon, I do attend the meetup. Yeah.
Okay.
Nobody else was there. He was in the voice channel. He still is in the voice channel. And he posted on the meetup page. Find the link. Yeah. You know what though? Like, fair meetup's in trouble. Our venue answers your anyway. Even like I haven't gotten any like
So it's proper.
It was propped open when I was there too. We'll give people 2 minutes.
Excuse me. The important people. Well,
I'm gonna get started. One here. Awesome. Thank you for coming. You're here, San Diego Python. You're in the right place. I'm glad you're here. Man, having your venue up in the air causes definitely attendance to go down. Too. Awesome. Anyway, I want to thank Ansir Cowork for having us. They've been fantastic. We were back at Ansir literally almost 10 years ago when San Diego Python was first getting started. So it's kind of like a blast from the past to be back here. Though obviously it was on the other side of Convoy back then, but so it goes. Anyway, I just want to thank them. So if you have co-working needs, this is the place. I also want to thank my co-organizer Jeremy, who has wrangled all the speakers and set things up. Make sure that we have good speakers for the lineup and everything like that. A couple other announcements, and then we'll get to some other stuff. We have a Saturday meetup. It's on our meetup page. So if you go to meetup.com or you go to our website, sandiegopython.org, it'll tell you about the Saturday meetup. That one's a little different than this one. Happens on Discord. Kind of a bring your own laptop kind of a thing because it's online. People are working on projects. There's not like a speaker lineup usually. So it's a little different, but check it out. On our website, sandiegopython.org, has links to our YouTube channel. This meetup is being live streamed, has all of our past meetups too. They all have like timestamps and stuff if you want to click through to the exact talk you're interested in. Has a link to our Discord. There's like a couple hundred people on the Discord. There's a jobs channel on the Discord, notably, which is a great place to like announce your job. At the meetup itself, there's 12 people or 15 people or 20 people, but on the jobs channel, there's more. Awesome. There's some upcoming conferences that I want to announce. So there's SciPy is in Austin, Texas in July. North Bay Python is in Petaluma in late July 29th to 30th. Gotham in New York City and online, October 6th to 7th, and DjangoCon US is in Durham, North Carolina this year, October 16th to 20th. So not in San Diego anymore, but it was a great run while I was here. Cool. I will put a link into the chat for the live stream, but there is a sign up for giving a talk at San Diego Python. I would love for you to give us a talk at San Diego Python. Jeremy and I are like the speakers of last resort, and so we love when there's a speaker lineup to allow us to not speak at San Diego Python. That's the best. Awesome. So I'll put it in there, or you can go to it's pysd.io/talk. There's also a link on the website, sandiegopython.org. So if you can't remember that, just go to sandiegopython.org. All the links to all the things, the meetup page, the code of conduct, the YouTube, the Discord, they're all on there. It's one page. Whole site. So yeah. Anyway, cool. I also want to announce our sponsor, who has a giveaway for today. It's PyPortal, but this is JFrog. They've been fantastic. They literally sent us giveaways in February 2020 to give away at our March 2020 meetup, which happened in October 2022. Super awesome. Actually, we were giving them away online, so I was like mailing them to people and stuff like that. But they've been fantastic for like, literally 3 years now, giving us giveaways for our meetup and stuff like that. So they've been super awesome, very helpful, super great. They're a DevOps platform for continuous releases. So if you need like a PyPI inside your company firewall, or you need like, maybe third-party Python packages scanned for security issues or stuff like that, that's kind of what their product does. If you're interested in that, you can check it out. It's JFrog. That's the name of the company, jfrog.com. I don't actually remember what their website is. I'm sure if you type it in, JFrog, you'll get there. Cool. Anyway, I have the giveaway. It's an Adafruit PyPortal. It's a CircuitPython-powered programmable display. If you win, I'd love for you to give a lightning talk on it, and I'm going to pressure you until you do, but just a little bit of pressure, not too bad. Awesome. So the first winner, I drew names off of the RSVP list at like 5 p.m. That is how I do this, so that I don't have, because I'm reading off the sheet, because all my devices are running the live stream. The winner, who I drew first, was Buka. Nope. All right. Ruben Jimenez. Ruben. No. All right. Nina Gasparo. Not looking. No. Edmund. Edmund. No. And Eric Kotner. No. All right. Graham, you're the winner. Graham, you're the winner. All right. And I'm going to fun pressure you into a talk. So. Yep. The pressure will build and mount until you give a talk every month. Awesome. Sorry. I don't know. I think it's. I don't know the model number. It's probably printed on there, but it's an Adafruit PyPortal. Yeah. All right. Awesome. I'm gonna check if our first remote speaker is here. Because I have to let them into the meeting. And that's probably because I started a little early. So maybe, Jeremy, why don't you give a talk first, and then we'll go to the speaker second. So Jeremy's going to talk to us about algorithms for interviews part 3, overview of dealing with Pandas DataFrames.
All right. So I've already heard, one comment tonight saying Python is pretty slow. And okay, how to deal with that with large data sets, what Pandas is good about. Over the past couple of years, Pandas has gone through a renaissance. They have switched their backend from having NumPy as their backend to Python Arrow. Now, what this involves is different, and we're going to hear a lot about the data types that Python deals with, and the data types that NumPy deals with. Lastly, the data types that PyArrow. So, an example of how Python deals with data types. If you're going to add two things together, what does that mean? So, if I have two strings and I want to say, hello plus world, in Python land, it might ask, what kind of data types are these first? Are these numbers? Are these strings? Are these floats? Are these complex numbers? And so it will just keep on going down until it finds data types that will most closely match what it's planning on or intending. So that check is so much of the reason why working in Pandas is going to be faster. Why do I say that? Because everything is columnar in Pandas. Everything, it assumes that the data type all the way down the column is going to be the same. So if you're dealing with an int 64, it's int 64s all the way down. That way, we can get rid of all of those, hey, is this a string check? Is this a complex check? we can just deal with one data type all the way down. This helps speed up Pandas. Now, in NumPy, it was able to deal with that one particular data type, let's say, int64, all the way down. But it didn't necessarily deal with nulls all that well, depending on what kind of column we're doing. So if it was a float, if it was an integer, it didn't have null values. It had to switch it to a float. So this is one of the nice bugs that they've gotten rid of now that switched backends. So I've got I called this particular function read the data frame slowly. In this, there's only two problems in this, and I would like you to take a look at this particular file name. Reading in a CSV file, it's going to tell us what, let's say 640,000 records. Going to iterate over the items in this data frame, and then we're going to apply this strip logic and set that back into the data. Okay, there's only two problems with this. One is line 31, and the other one's line 33. So it's a big problem. Let's see. There's some things that you can do to speed up the way that Pandas accesses items and also places items. This is not a good way to iterate over a data frame. You don't want to go row by row on anything because it might have to look up those particular data types every time. If you're going to, other red flags in this are if you see a lambda function all by itself inside the apply, another red flag, then you know that you're not using some of the data type optimizations, these ufuncs that Pandas can do. So careful. I have an isInstance method in here. Once again, it has to do a lookup of what kind of thing this is. So these are all problems. And if I saw this particular type of code in an interview, I would say they are doing this wrong. It will get it done. It can get it done depending on how big the data is. How long will it take this complete? In older versions of Pandas, this would have taken a lot longer. Newer versions of Pandas, it changes the format underneath. Show you how some of these are sped up. So this is not a good way to deal with it. So how is a good way to deal with it? The first thing that you want to do is deal with a data frame on a data frame level. What do I mean by that? If you want to turn the entire data frame into strings, for example, you can say, I would like to treat the entire data frame and put a .str example, or a .str accessor method on the end, and then you can treat everything as strings. Let's say like you want to make it all lowercase. Now you can deal with everything inside that data. Another way to deal with these is whenever you read in the CSV file, there's something called converters. You can deal with each column inside that data frame. You just pass it a dictionary. Say, okay, in this particular file name, I have addresses. Okay, addresses are strings, but I have the person's age. The person's age, in this case, is an integer. I would like to make sure to map all of these data types. That maybe I have a date time. I can say, hey, this particular column is the _date time. So you need to deal with data frame whenever you're reading it in. Now, Pandas has some knowledge of what types of data to bring in, there is some difficulty when doing that. Let's say, for example, you have phone numbers. Phone numbers can be integers, okay? But you have to deal with the formatting of those integers, whether or not they put the parentheses around the first, or around the area code. Thank you. Around the area code, did they put a dash? Did they put periods? Did they put an X for a phone extension? Those types of things. So how does it read that particular thing in? So there might, you want to specify that in the converter dictionary. Have a function specifically for phone number, reading in phone number, different types of phone. That would be dealing with the data frame on the data frame level. The next thing that you want to do is deal with individual columns. The reason for it, we went over the data types, is to be able to treat the entire data type, or the entire column with one data type. Or all of them are integers, all of them are. So an example would be something like an accessor method. So df dot addresses. Addresses is already read in here in the data frame. Dot str dot lower. I wanted to change all the addresses to lowercase. This is a way to lowercase those addresses, but I need make sure to set it as the column after. This is dealing with things faster and also not having to change the data types. The next thing, this one is something I'm not going to go over tonight because I didn't think I would have a whole lot of time. But let's see, which is if statements. If you were going to put an if statement inside your for loop, you're usually wanting to deal with some group of a particular part of the data frame. So df.groupby is one of these, methods to help you constrain where this if is going. The other operation is a pandas, or no, pandas.where operation, or numpy.where. Same thing, but now it's going to be different. So in a numpy.where scenario, it can work just like an if. If you wanted to change certain values, let's say, for example, all of your addresses have street at the end, STREE spelled out, and you want to abbreviate that. So you can use a numpy.where and find those particular values. This would be a more vectorized way of dealing with those values than having an if statement read every single one of those rows with without the data types. All of this changed. Or let's see, at the probably beginning of this year, Pandas 2.0 came out. This uses a backend, or a newer backend called Apache Arrow. Apache Arrow was developed by the same person. PyArrow. Let's see. This is the Python interface for. Oh. Let's see. Yeah. The Arrow Arrow project was developed by Wes McKinney, same person who developed the original version of Pandas, and so he's thought about how to fix some of the problems in Pandas, and we want to thank the maintainers of this. Wes McKinney gets a lot of attention for having developed this. But Jeff Reback deserves a lot of credit for project. Being able to merge. Let's see. We're going to see that the version for the latest version is going to be able to uses, I believe, an architecture called Numba or underneath, which is able to take all of these commands that you pass in. Let's say like this apply lambda or is instance code. It's able to turn this into the fast representation, vectorizing these commands. So now you can even throw in junk. It will come out fast. This didn't used to be the case. So you'll notice, let's see, the fast execution time versus the slow execution time. We're talking 2.6 versus 3.2 as far as execution time on a little more than 500,000 rows. Able to figure out what types to put these in. There's not much of a difference here. It used to be quite a bit bigger, let's say 4 seconds and 6 seconds. So it's going to, your jobs are going to depend on how well you deal with those data types. But if you are able to say it explicitly as to what data types you're dealing with, you're going to get a faster optimization. There are other types of data files. I would suggest using those more than a CSV file. Parquet. Parquet is basically like a zip file. It's able to be loaded into memory. They use a couple of tricks to be able to speed up the reading of this data. For example, if all of your integers in a particular column start with 100,000, well, what they'll do is they'll say, okay, subtract 100,000 from all of these and just deal with the small digits, 1, 2. So that's one of the many tricks that they have to large data files. I would go ahead and read in the Parquet file. It will read in the specific data types with it. Then you don't have to go through a lot of conversion stuff. And here's some examples. Speed increases with a Parquet. All right. So how is let's say arrow faster than NumPy? It's able to deal with missing values. There's something called nans, not a number. And if you have those missing values, NumPy wasn't able to deal with all of the types of missing data. So speed. Parquet is a lot faster at process one of the rows. Interoperability. There is library out there. I don't know if any of you use AWS. One of my favorite ways is to use a Lambda layer. Be able to deal with this. Modules that it can deal with are things like Redshift, MySQL, Postgres, SQL Server, Oracle, Gremlin, Spark, OpenPixel, OpenSearch, or Delta Lake. So all you have to do is specify the ARN. Be able to put that in. So let's see. more consistent data types. It now has integer with NAND, float, and NAND. Boolean, or its idea of a Boolean is 8 bits. A little wasteful. Okay, and lastly, copy errors seem to be a thing of the past. Recreate one that usually you would have some section of data frame and you wanted to put that in, and it would give you a warning saying, oh, I'm sorry, you can't, you're copying a section of memory, give you a warning based off of this that maybe it's mutated. It always seemed to work. They would give you, right? But due to this, it's now a thing of the past. Anyway, I wanted to leave it open for any questions about what are the changes? Yes.
So is the changes by 2.0 this swap out?
Yes. Let's see. It still has NumPy operations data type that it's stored in data frame by arrow. So it's Pandas is an interface, or it seems to be an interface layer on top of a lot of pi arrow functions. No, it's not passing it on to NumPy. Pi arrow is this format. Its own storage.
NumPy. Oh, right.
Let's see, it was a bit of a mea culpa. But, hey, I'm going to bring out this old presentation. But, oh, it doesn't work. Let's see how the presentation was. I know that there's interoperability between them because of the Pi Arrow project. I haven't needed to mess with pullers. I have messed with Ray, Modin. It works very well for, or as far as interoperability goes. I haven't had much need to scale this up yet. We haven't. As far as the business that I work with, we haven't gone into trusting this yet. So anyway, but I'm desperately looking into using this. K files are so much better than C. No, we'll see. It's I would say it's a binary file format. It's like a zip file. It's highly compressed. There's relations on certain data types, like I was saying before. Saying.
So our next speaker is remote. So we flip it around and see if the magic happens. Or we might have to play this work. So we're going to flip it around. That'll be okay. Lost something though. No signal.
Oh.
Did we lose the HDMI?
Yeah. It's just input connections now. Okay. One.
Yeah, maybe we'll just try the unplug and plug it back in and see if the magic happens.
Something else detected. You want to put connections now? This.
Let me just. I'll do the same thing here. And we'll see if these magically work. Oh, the USB came out, which powers this thing. So that probably did it. Let me try this again. Why don't you try full screening Axel and we'll get the sound ready. Oh man, this would be terrible if we lose this because of our stupidity.
Gee, maybe this in.
I don't think that this end matters really.
Oh,
But
no.
because I see it powered here.
Oh, okay.
Here, I'm gonna unplug all the things, start it from scratch. Hopefully,
Thank you for waiting.
everything comes back.
You're engineer start.
Yeah. Hopefully, I plugged these into the right ones. Yes, out and in. No, come on. This is the worst. Why am I so bad at this? I don't think that that's it. I think it's. Oh, this is terrible. We just lost. We had it up and now it's not working.
All right.
Well, it was up. So I mean, unless it switched the display when we did that. Here, I'm gonna try this again. Oh, terrible. Sorry, everybody.
Oh, it is working.
I don't. Oh, it could have. It could have come out of the TV, actually. I'll check that. That's a good thing to check. Plug it back in and get that goes. That's in. So this needs to go into, yes. So that goes into the out. Just comes up. So could we unplug that and plug that in too?
Yeah.
Or I wonder actually, do you think your laptop switched inputs or something?
Hmm.
Turn the TV off and back on. Yeah, we could try that too. Sorry, Axel. Hopefully we'll turn it off and back on. Or don't unplug the TV.
All right.
If we fail here, we'll just we'll lose the live stream and we'll just put it directly from the TV into the laptop. And I'll test the HDMI card again later. Hopefully we didn't break it somehow.
Reaction. Turn
Right on. All right. TV came back on. No signal. Cool. Here, excuse me. I'll scoot by you. This is terrible. How did this happen? No. Are you checking the inputs? Oh, you are checking the inputs. So I'm pretty sure this is just HDMI 2, bottom one. You're plugged into this, right?
You have your screen sharing on?
Well, it's, I mean, if the display's up.
It came up for I saw something for a second there.
Did you?
Yeah. Can you check your other display?
Yeah, I wonder. Don't think so. All right.
HDMI to.
Well, all right. I'm about to call it. What do you think? Should we just plug it directly in? We'll try that. See if we have better luck. Cut out this. Sorry to all the people on the live stream. Does that do it?
Doesn't look like it.
No. That's weird.
Are you sure? You have the second display on?
I wonder if when we yanked the displays, we lost something. Bad days. Break your HDMI plug. Could also
try putting it into HDMI.
I could try that.
If not, I can do it on my computer.
Yeah, I guess maybe that's the other option. So I just
All right,
plugged it
so
in
now it shows
HDMI
one.
1. I'm gonna press up and see No, still no signal. Oh, something. No signal. All right. I guess I'll leave it on HDMI1. But it seems like there's a problem either coming out of the laptop or something. I'm sorry, Axel. We just had some connectivity problems.
No worries at all. That's all good. Actually, I have like a couple of teammates and they messaged me that they can't hear me when I was talking. And then all of us had some challenges with the time the phone work. I mean, no rush.
Okay, give us like 3 or 4 minutes, and hopefully we can get this going.
Yeah. I'll just go grab some water or something.
Okay. Jake, I'll send you the link to the meeting.
Can everybody just get on Discord real fast?
No.
No.
Like they're on a Google Meet.
And then you
Sure.
your Discord though.
I can send Drake the Meet link. That.
I'm going to get this out of the way. There it is.
I don't know what happened there. Be very sad if this doesn't work. Here, let me I guess maybe we'll. Can I try the mirror box before we? Or you're still connecting up, right?
It's not ready yet.
Oh,
You can.
I'm sorry, Jeremy. I don't know what happened there.
No.
Hopefully we can do a little better. Okay, that's the out.
Go ahead.
Hopefully this just works. Are you on the Wi-Fi?
Not yet.
Okay. I'm just gonna. Oh, we're still not getting anything. This came
Yeah, let
unplugged.
me. It's doing
Oh.
something.
Yep, it's connecting.
All right.
Well, that's a positive. Yeah, why don't you move the laptop so that it's facing this way? So 1, it's closer, and 2, so that yeah. Well, this is good at least. So this is a positive. I'm gonna move
How do you
the.
get to Google Meet?
I sent it to you in Discord.
Okay.
Yeah, so it should be in your Discord. The old technical issue, and then I have to mute our microphone.
Correct. So it would be. All right, so you guys can see my screen, right? Oh yeah, yeah. The screen is more important than my face in this. Thanks. All right, perfect. So yeah, we are from Meetup, which is an early stage startup. We're located in California, just as you all are. However, in the colder part of California at the moment, at least, it's like the third winter in San Francisco. We're located in Santa Clara as a company. So we started this project a couple of years ago, doing some research. Avi and our CEO Masi did some research on under a Japanese corporation's innovation lab called NECX, and then the project span out from there. So all that Meetup really is, it's a static code analysis tool that is used to ultimately cut debugging time in half. That is our goal. So I'll move on to my next slide here, which is just why we basically started this whole thing, which is simple. Debugging is very time-consuming. It's very and costly for companies as well. So there is a validated business opportunity in this as well. And at least in my personal opinion, it also sucks to spend your time like catching your bugs from your source code. So this is what brought us to this. And according to our original research, before we started the project, 50% of an engineer's time, especially in larger companies, is spent on debugging on average. So this often becomes a bigger pain whenever you're inheriting a more complex code base, more complex and larger code base in your environment. Moving on from here, just a little bit how Meetup actually works. So before I jump into further parts of this slide, to give you a basic understanding is that Meetup is a two-part system, the product itself. So to detect problems, we actually don't use yet generative AI models. So that's how we are actually different than anyone else at the moment. And what we do for the detection part is that we have trained a graph attention-based neural network for it. That neural network is trained on millions of bug fixes from multiple different data sources. These data sources include high-quality open source repositories from GitHub, Bitbucket, company SOPs, mostly GitHub actually, company SOPs, some design standards even, as well as manual review results. To clean up that noisy data set that we get from these sources, we use a lot of different topic modeling techniques. So basically, to clean it up, we currently have a data pipeline where we use a BERT topic model that analyzes different code changes within these data sources, and then determines why specific code change was performed based on the surrounding documentation that is provided for the code change. So with these data sources, our AI agent has the ability to learn the best programming practices. So it learns to detect the root causes of many complex problems that cannot be detected with just manually defining rules, such as like normal static code analysis tools, such as Sonar, for example, do. So instead, it learns to analyze the whole surrounding documentation, the code context, and then detect the problematic patterns in code that it has seen in the training data set before. With this, we then store the problematic code and the surrounding context information about the code base and its intended purpose, the intended purpose of the code. And then we pass that to a generative AI model that then can produce, using the contextual information as well as the problematic code, context-sensitive problem descriptions. And we also, which is like a newer feature, we also allow users to request the generative AI models to produce code fixes automatically for the problems that it has detected. So with this, what makes it effective compared to rules-based tools is that rules-based tools such as Sonar, Deep Source, are often pretty limited in terms of their detection capabilities. So they mostly focus on like detecting simple syntax errors, spacing and styling errors, typos, readability, as well as one of their most useful use cases, at least in my opinion, the commonly enumerated security vulnerabilities. So for example, OWASP top 10, CWE top 25, which can be detected by defining preset rules and using rules-based algorithms. So then when it comes to that compared to our system that we utilize is that since the AI is trained on millions of bug fixes, it recognizes the root causes of different logical and context-based problems as it interprets the existing architecture of the code, and then we can work backwards from there to build it. So actually our models are language agnostic. However, we at the moment only support Python, as we want to first finalize that and the detection capabilities to its best best uses. So some of the issues that we can detect that the rules-based tools at the moment can detect using this AI technique for the static code analysis are, for example, stemming from misuse of different modules, process sharing, as well as multi-threading issues, then platform-specific problems, for example, with Django, as well as race conditions, memory leaks. And actually, at this point, we have reached over 120 topic categories that we can identify bugs from. So each of these categories have hundreds of different bugs that are involved in them. To move on from here, a little bit more about our approach is that we utilize an attention mechanism within the graph neural network that we have, where we comprehend both semantic and relational markers, which are resulting in more accurate detections. We then, to train the model, we leverage human-reviewed historical improvements to predict where bugs occur. So basically what our AI does, it intends to replicate the code review process that humans would perform. So it is trained on data where humans have labeled a bug, basically, or like described the bug and then fixed it. So we look into the associated code change as well as the documentation about that. Then more recently, with the advancements with generative AI, we have been able to utilize those to generate problem descriptions using those models, as well as resolution for the detected problems. Our system is ideal for detecting, classifying, and fixing problems that arise from complex problem categories, such as mentioned race conditions, unhandled edge cases, and API mismatches, when rules-based tools, such as Sonar, for example, are ideal for detecting more simple errors, where you can utilize rules-based algorithms to detect them. These tools, as mentioned here, use predefined rule sets to detect problems in code, and the nice part is that usually those rule sets are commonly available for the public. For example, Sonar even provides most of them. Then LLMs are a part of our product, but we don't necessarily compete with them, as they are not intended for the same purpose as we are. Obviously, LLMs are models that are trained on billions and billions of parameters. I guess GPT-4 will be trained on trillions of parameters, and they predict the most likely token based on the given user input. Their ideal use, however, is not to necessarily analyze code, but instead create code using LLMs. Actually, a pretty good pair to work with Meetup is that people now more and more use AI to generate code. However, AI doesn't necessarily generate clean and optimized code or problem-free code. So some of our own engineers, as well as some of our users, they use first AI to generate code and then Meetup to analyze the code to optimize it and find problems from it. All right, so then moving on from here, a a little bit about our technical moat, as it is a pretty competitive market at the moment. So I'll try to make it as clear as possible how we differ from other tools at the moment that are available, for example, on VS Code. One of the biggest ones is definitely our context-aware detection. So because we use a different kind of method to detect problems, we are able to store more contextual information as well as analyze the whole code base at once. So we can detect problems from how different parts of code interact with each other. This is something that is limiting current LLMs, for example, GPT-3, from analyzing, as the context window is only able to take in 3,000 tokens, if I'm right here. So yeah, then actually last week, one of our research partners from Dalhousie University, a university located in Canada, presented this problem identification method and technique at ICSE 2023, which took place in Australia. And I believe it was actually just last week. So that is also, the paper is available now for people to take a look into. Then another part of here is the proprietary classification. So we use a unique methodology that enables specialized problem identification from noisy raw data, which outperforms the off-the-shelf techniques to its supervised nature. So this is where our topic modeling system and data pipeline comes into use. So we use it to classify why a specific code change was performed by the given engineer through the descriptions and documentation they provide with that code change that they pass. So for example, this data comes from GitHub issues, pull requests that are openly available, as well as in some cases, we also try to utilize, for example, Stack Overflow data to generate that for the model training. And as mentioned earlier in this presentation, we have been able to identify over 120 unique categories, which each cover hundreds of different bugs within them. So these categories are such as the API, internal API mismatches, as well as, for example, CPU, GPU, runtime environment, initialization errors, as well as unhandled edge cases ranging all the way to, for example, memory leaks. Then lastly, our model learns from user interaction, as well as the historical learning adaptation. This is kind of like a feature that enterprises are more interested in. We don't necessarily use user data, or we don't use user data to train our own model. However, in enterprise environments, it is actually often requested that they provide us data about their previous code changes as well as bug fixes, which we can use to train our model and tailor it for their specific use cases to basically help them avoid similar problems in the future. So as it is an AI model, instead of something that is hard-coded rules, it has the ability to learn from historical data and code commit histories. Then just lastly, I have listed a few of our different problem categories. It's a quite busy map if we list all of them here. So just while I make sure that I have our demo open, you can take a look into that. At the moment, does anyone have any pressing questions, or should we just go for the demo and look at the Q&A afterwards? All right, sounds good. Let me quickly change which screen I'm using. So we have a couple different integration methods available at the moment, mostly for individual users. We just recently released our first version of an IDE extension, which is in this case for VS Code. We will expand to other IDEs once we have the first one perfected in a perfect form. But let me just share my other screen. So this is just a 1-minute demo of our VS Code extension, which is a free tool for all individual users that want to use it through VS Code. So the use of it is pretty simple. You just first open your code, request an analysis, then it highlights different problems in red. You open them by clicking more details. You get an explanation here. I can stop it for a second. You can read here what the problem category stems from program logic, and here is a description, which is a pretty lengthy one. Then in this demo, what happens next is that I'll ask a question about the problem itself to get a better understanding what is exactly going on. So all that I do is ask, how do I fix this on the client side, and ask. Yep. And it gives me kind of like similar to different LLMs chat log here, as it explains me where it actually needs to be fixed, which in this case is the server side. From here on, we'll move on and ask for an actual code recommendation to fix the detected problem that it found from the code, which also takes a minute, and then provides that, and then you just apply it there and fix quickly the indentation, and that is the whole product in all its simplicity. I don't know if that went by too quick. If you want to see the same demo quickly again, I will obviously also provide the link to the tool so everyone can use it by themselves. And actually at this point, we're very much looking for feedback on the tool as much as possible. So this is what we currently have built. And now if anyone has any questions, please go ahead. Actually, Avi can take this. It's based on a lot of things, so Avi, go ahead.
Yeah, you're basically correct. It's all three of those things. We're looking at the surrounding documentation around every code change. So essentially, if there is a issue or PR that's been associated with it, or multiple ones of those, the comments from that, the commit messages, the README changes, any other documentation like updates either inside the code or within the code context. We pull all those together, and then we're able to essentially assign in two stages. Firstly, whether or not something is a bug fix or like a new feature, and then secondarily, whether or not it's something that we should detect or not based off of what category it falls under and what prompted the change. It's been about 3 years in total. The first year was mostly spent, as Axel mentioned, we were working with NEC in Princeton to do some research into code fault detection. Through that, we stumbled upon this method, and we started building up the data set and use cases, and we've been working on it since then. Yeah, so luckily, the way that we are encoding the actual like code context, so when we're building this like graph of the code base, it's similar to the abstract syntax tree, but we also augment it with the program flow, conditionals, as well as some additional semantic markers. And these additional semantic markers include both the types of words that we use to describe like variable names or function definitions, as well as how they're located and how they're set within the program itself. And that's ultimately what we use as our like base features. And because we're not encoding like specific words or specific like variable names or things that we're looking for, but instead we use like a subgram encoding to get similar patterns or similar matching sequences. We're able to keep, like, if you have a 20 word with all underscores kind of variable name and the letter A, they're both meaningful in different ways in terms of how we analyze the code base. Yeah, I mean, long story short, yes. They're part of the embeddings that we use for the neural network. So yeah. Yeah. So basically, for Django, you can there's like a task worker system that they have as part of the like default configuration for Django. In there, you can encounter all sorts of different like race conditions or other issues based off of how you set that up, and also how you end up using it as part of your application. And these are the sorts of things that we can detect. So there are problems that would occur at runtime, maybe only under certain conditions, but are going to be serious when they do occur. And they're rooted primarily in the architecture, the decisions that were made while building the code base. So rule-based tools won't be able to help you there because it's very hard to generalize, like, oh, if you have this set of, if you're processing this sort of data with this kind of worker, and you're making this API call and you're not handling these sorts of exceptions, then it could get stuck and you'll end up with a dead worker that will need to restart, and then you'll have a deadlock, right? So things like that we can more aptly find as from a rules-based tool.
And I think something that usually isn't found with Sonar, at least to my knowledge, is like unhandled edge cases, because they need to examine like all the intended uses of the code. So that's what usually our customers are also providing like feedback on, that is something that's new from the like traditional static code analysis tools. Yep. Yeah, thank you for letting us come here. I can drop the link. It's pretty simple. So if you end up trying it, please provide feedback on it and just your honest and general thoughts regarding the tool. It's obviously free to use for everyone. So I'll drop it in the chat as well as my email. And yeah, just feel free to reach out with any questions, or if you're interested to learn more about the tool, we're always happy to give a more detailed description. And we really appreciate you guys having us here for this time. Thank you.
Yeah, have a good one.
Bye-bye. All right, sounds good. Thank you so much. Have a good night, and enjoy the sunny weather of San Diego. Bye-bye.
That's important. Without the mic volume, you can't hear me. All right. That pretty much wraps things up. I appreciate everybody like dealing with the AB issues that we had. I want to thank our speakers, I want to thank Ansir for having us and JFrog for the giveaway. Thanks, and thank you to come. Remember, if you want to give a talk, you can sign up to give a talk. There's a link on sandiegopython.org to sign up. You don't have to sign up for the next meetup, although that would be great. You can sign up for a future meetup. I also wanted to just mention Drake brought some snacks, which are in the back of the room. Thank you. So please eat them. And some of us will probably be going to O'Brien's. Like, we have to clean up here. Like, I have to put all the chairs away and stuff like that. But some of us will be heading over to O'Brien's. If you're interested in that kind of a thing, there's no pressure, but you're welcome to join us. Thank you. And that's the meetup. And the live stream.
Yeah, close.
Yeah, we had a little bit of live production.